Bismillahirrahmanirrahim. I thought we tried this problem, so let's read this together. In a right triangle, the larger leg is 5 more than the smaller leg. The hypotenuse is 1 more than twice the smaller leg. Find the length of the hypotenuse. Okay, first thing I'm going to do is to draw myself a right triangle like this. Now, it doesn't really matter how it looks like as long as one leg is larger than the other one. So here's a right triangle. Of course, a right triangle has 2 legs and a hypotenuse. That's over here. That's the hypotenuse. So in this case, this is going to be my smaller leg, and this is going to be my larger leg, and that's going to be the hypotenuse. Okay, got it. Now, in a right triangle, now this is very important because it's no ordinary triangle. It's a right triangle. I have indicated that by that symbol there, which stands for 90 degrees. So I have my handy dandy right triangle over here. The larger leg is 5 more than the smaller leg. So I don't know the length of the smaller leg. I'm not told how big it is, so I'm just going to call it x. Okay, if the smaller leg is x, then the larger leg is 5 more than x, right? So this is going to be x plus 5. Then I'm told that the hypotenuse is 1 more than twice the smaller leg. In other words, if I take the smaller leg and multiply by 2 and I add 1, I get the length of the hypotenuse. That sounds pretty good to me. The hypotenuse is 1 more than twice the smaller leg. Okay, find the length of the hypotenuse. So what are we going to do? Well, we're told here that this is a right triangle. And as you recall from the Pythagorean Theorem, the sum of the squares of the legs of a right triangle equals the hypotenuse squared. In other words, if the legs were a and b and the hypotenuse was c, a squared plus b squared equals c squared. So if a and b are the legs of a right triangle, then the sum of the squares of the legs equals the hypotenuse squared. So that's the Pythagorean Theorem. I can use the Pythagorean Theorem to solve this, see? Then I can say a squared, which is going to be x squared, and it doesn't really matter which one is a and b because you're just going to square them all. Then I have b squared, which is going to be x plus 5 squared, is going to equal to hypotenuse squared, which is 2x plus 1 squared, okay? Now I'm going to solve this. How am I going to solve this? First, I'm going to expand these, which means that we'll do one of these. I'm going to x plus 5 squared equals, well, x plus 5 times x plus 5, right? Then I can use FOIL. That's going to be first, outer, inner, and last. 5 times 5, that's 25. And you can simplify this. X squared plus 5x plus 5x, that's 10x plus 25. So that's what you would do. Unless, of course, if you knew the formulas, which are as follows. A plus b squared equals a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. You can't escape these, see, so you might as well memorize them. So it's a plus b times a minus b, okay, is a squared minus b squared. So these are pretty important. If you don't know these, why not? You might as well memorize them. Take some time to just memorize them, okay? So, but if you didn't know these, you can just write them out like this and do it longhand like this. Now, in this equation, then, this is a and this is b. So you can use the formulas to do this. So I'm just going to rewrite that over here. That's x squared plus, now I'm going to expand this using the formulas because I'm brave. Okay, so that's going to be a squared plus 2 times a times b. X is a, 5 is b, plus b squared, which is 25. And I could do the same thing on the other side. In this case, a is 2x, a squared, that's 2x squared, plus 2 times a times b, b is 1, plus b squared, 1 squared is just 1. Okay, then I'm going to simplify, because that's what I like to do. 2x squared, I love simplifying. 5 times 2 is 10x plus 25. And then you have to be careful here because this exponent applies to both of those two things. Okay, so that's 4x squared plus 2 times 2 is 4x plus 1. Okay, now what do I do? Well, I have variables like on both sides. Okay, so I have to get them all on one side. So I'm going to get this 2x squared and this 2x squared together. So I'm going to subtract 2x squared from here. That's 2x squared from here like this. Okay. Then I get 10x plus 25 equals 2x squared plus 4x plus 1. Alright, then I gotta get everything else on the other side. So minus 10x minus 10x. Okay, let's get everything on this side. So now I have 25 equals 2x squared minus 6x plus 1. Okay, well, might as well get the 25 on the other side. It's like everybody wants to go on the other side. 0 equals 2x squared minus 6x minus 24. Now I have to solve this. This is a quadratic equation. There are 4 ways to solve this, right? Graphing, not going to happen. Factoring, maybe. Completing squared, no way. Quadratic formula, maybe. But before we do anything, but you see, you gotta look. So look, there's a 2 over here, there's a 6 over here, and there's a 24 over there. I think I could divide every single thing by 2 to make my life easy. And that's always good. Okay, so let's divide this by 2. Divide the whole thing by 2. So here we go. When I do that, I get 0 divided by 2 is just 0. This is x squared. And then this 6 divided by 2 is 3. And then this is 12. Oh, that's much more reasonable, right? Here we go. So now I have to solve this. How am I going to do that? Okay, here we go. I'm just rewrite this. Okay, 0 equals x squared minus 3x minus 12. Now, you realize, of course, I could just write this. X squared minus 3x minus 12 equals 0. Okay, now I could try to factor this, okay? Seems factorable, but, you know, if you try, it doesn't work out, okay? You go like this. And so factors of 12 are 1 and 12, 2 and 6, and 3 and 4, okay? It doesn't work out, unfortunately. So you can try, but I don't think this is going to factor, okay? So we're going to use, of course, the famous quadratic formula. X equals opposite of b plus or minus square root of b squared minus 4ac over 2a. Oh yeah, 2a. Don't forget the 2a over there. It's a cool formula. Now look, so one step, x equals opposite of b. Now b here is negative 3, okay? So you have to take opposite of negative 3. Okay, plus or minus square root of b squared. Now b squared again is negative 3 squared, okay? Minus 4 times a is just 1, okay, times c, which is negative 12. Alright, so my square root sign didn't go, there we go. Now we're good. Over 2 times a is again just 1. Alright, now I just have to simplify this. This is going to be 3 plus or minus square root of 9 plus 48 is 57 over 2. Now this is going to be 2 answers, okay? That's going to be 3 plus square root of 57 over 2. And it's going to be 3 minus square root of 57 over 2. Now this answer is not going to work because that's a negative number. Because, you know, the length of the leg can't be negative. It's like, what kind of triangle is it? Like the leg is like minus 5. What does that mean? Okay, so it was going to be one answer, and it's going to be this positive answer over here, okay? So that's x. So x equals 3 plus square root of 57 over 2, okay? But the question didn't ask us to find x. It asked us to find the hypotenuse. The hypotenuse is 2 times x, which is 3 plus square root of 57 over 2 plus 1. So, okay, that's not too bad because 2 times x, they just cancel out over there. That will work. I like that. So 3 plus the square root of 57 plus 1, and I can simplify that to just 4 plus square root of 57, and there we have it, and that's the hypotenuse. So always read back, make sure you answer the question. So what did we do over here? Well, we took a word problem over here, and then we used the Pythagorean Theorem, and we did all this fancy math, and in the meantime we reviewed these 3 special case formulas which help us out, and then we tried to factor, didn't work, and we used this surefire method, which is the quadratic formula. It looks very fancy anyway, and then we found the answer. I hope that helped. Until next time, assalamu alaikum.